Greetings and salutations, everybody. Welcome back to English 102 for the day 2. You made it through that first day's rant about the syllabus. So now you're actually going to learn things, I hope. So here we are. Usually on the first day of English 102, I usually like to go over some basic fundamentals of logic, reasoning, how we reason, why we reason, the different types of reasoning. So that is an activity that we're going to discuss today. This is almost kind of going to be a philosophy lecture more than anything. So I always find it helpful just because it sort of gives you a nice framework, for how to approach a class like this. So there's going to be two types of reasoning. Two types. A little bigger for you. So two types of reasoning. The first type is called deductive reasoning. So basically what deductive reasoning is, it's always 100% accurate. There's no doubts left in deductive reasoning. Deductive reasoning is mathematically correct 100% of the time. So the question is, what is deductive reasoning? What kind of forms does it take? Usually with deductive reasoning, it takes the form of math sometimes. So just this is about the extent of my math knowledge, as a English teacher. But if we say 2 plus 2 is 4. Oh, goodness. 2 plus 2 equals 4. So, if that statement is an argument. If you read the logic textbook for today, it talked about premises and conclusions. So a conclusion, is the end result of an argument. Premises are all the building blocks, leading to that conclusion. So we basically have two statements here. We have the number 2, and then the other number 2. Put those together, that makes 4. That's an argument. Never in a million universes is this problem ever going to be different. Unless you say 2 plus 2 equals 5. That's reality now. That's some George Orwell stuff, right? 2 plus 2 will always be 4. The other form that it takes is called a syllogism. Basically a syllogism, it's almost like word math, as you'll see in a second. So the most famous syllogism in philosophy, all humans are mortal. Socrates is a human. Therefore, Socrates is mortal. So if you look at this, we have to sort of put mathematical variables over all of these different ideas in the syllogism. So think about an is and are. That's almost like an equal sign, in a math problem, grammatically. So if we put an A over humans and B over mortal, we have A equals B. Then we put a C over Socrates. C equals A. Therefore, C must equal B. That's the old adage. I think it's called the distributive property in mathematics, right? So that is always going to be 100% accurate. There's no disputing this statement. Just by the rules of logic. A equals B. C equals A. Therefore, C must equal B. That's just error-proof mathematical logic. Sometimes you can, put sort of crazy things in as variables here, and it'll still add up mathematically, but it doesn't have any bearing in reality. So let's say all humans are fish. Socrates is a human, therefore Socrates is a fish. Now that doesn't make any sense, but it's 100% true mathematically speaking, but that doesn't have any grounding in reality. So that's where deductive reasoning sort of loses its edge, as a type of reasoning. Usually deductive reasoning is mostly applied in philosophy courses, and that's the main way that philosophers reason. Just give you a brief history lesson all the way up until about the Renaissance, so about 16th, 17th century. That was the main way that people reasoned. That was how knowledge was accumulated. So if you, like, let's say the Islamic physician Galen, that's how Galen sort of, came up with many of his theories about medicine. He did this through this kind of reasoning. Philosophers use this kind of reasoning, to try to prove that God exists. Instead of having three statements, they would go up to 30 or 40 statements trying to prove his existence. But as you see, there's limitations to this kind of reasoning just based on what I just discussed. With that said, I'm telling you this because if I see logic like this in your papers, I will be very impressed. But, this is an English class. Pretty much all the classes you take besides math or logic, will be the second type of reasoning. We call that inductive reasoning. So inductive reasoning, if it can't be 100% accurate, what's the furthest number that it could go up? So 99.9999 into infinity. That's how inductive reasoning, the amount of probability, it can go up, to that number. So let's say that you take something like the law of gravity, for instance. The law of gravity, is a scientific law. You think, well, there's no disputing gravity. It's an undisputable universal truth. But you see this pencil, we throw it up in the air, it comes back down, to Earth. That's gravity. But here's where things are going to get a little weird. So prepare yourself. Nobody has ever thrown a pencil in the air 100 million times in succession. Nobody has tested the law of gravity to that extent. So if I would sit here the rest of my life throwing this pencil in the air, who's to say that on the 100 millionth time that it might float in the air, right? So you might say, well, Professor Yeager, you're crazy. You would never do that. Well, that's science. That's inductive reasoning. Things become true up to 99.9999. There's always that small chance, that, it'll be proven wrong. If we think about it, there's several points in history, where something that was universally true one day wasn't true the next. If you think about something like Copernicus, discovering that the solar system, the Earth revolved around the sun. Up until Copernicus, the Earth-centered model, was the center. The Earth, the sun, all the other planets revolved around the Earth. When Copernicus published that book, he published it on his deathbed, and because he knew that Roman Catholic Church, who had a lot of power at the time, would not like that idea, just because, well, man must be the center of the universe. So if everything doesn't revolve around the Earth, where man is, that kind of diminishes our importance, in the cosmos. So that's an instance where something that was true one day, just in a sweep of an eye with a new discovery, wasn't true the next. Also several other instances students usually come up with. The Earth being flat, is a pretty common example. Of course, there's still a few crazy people out there who say it isn't. It is flat. So we're diving into conspiracy theories here. But that's one. And usually they say, well, we haven't proven it to the full extent that it's not. It's the Earth flat's one. Even if we think about things in physics, somebody like Albert Einstein completely changed physics. He completely rewrote the Newton model of physics. When he came up with this theory of relativity, quantum physics, which is a new trend, that's almost rewritten Einstein from the ground up. So as you see, science is always constantly changing. It's always constantly evolving. So I go over this. I go over this for the simple reason that this is a persuasive writing class. So ideally, when you're trying to persuade somebody to do something, you want to get as close to 99% certainty as you can. But just to give you some legal examples, for example, let's say that you're trying, to sue someone in a civil case. You're trying to prove, well, somebody hit my car. I need damages in return for my car. Maybe you had medical problems if somebody hit you in a car accident. I need reimbursed for that. So, like for instance, a civil law case, the burden of proof as far as how much you need to prove that argument is 51%. If you can prove 51% to 49%, that this is the way it happened, a civil case, you will win. So that's why civil cases can go either way most of the time. It's a lot easier for a defense attorney, to prove, well, damages haven't been done, because all that defense attorney has to do is prove up to 51%. But let's say that you are accused of a felony, a criminal case. Now, if you're accused of something like a felony, that burden of proof changes because, well, if you're going to lock somebody up for life or for 30 years, or 10 years or whatever, you want to be absolutely sure to the extent of your understanding that that's true. So usually the adage is, if you take like a law class, 76% is the burden of proof that you have to meet for a criminal case. So that still leaves 24% room for doubt. So that's called proven beyond the reasonable doubt, that something happened one way or the other. So if you're accused of, like I said, you see the problem even now with criminal law. There's still that 24% room for doubt, which, if you play a strategy game, sometimes that 24% comes back to bite you, right? So now you see how that can become a problem. Usually in a class like this, we're dealing on a lot of subjective matter. Most of it's going to be, opinions. So whenever you pick your topic leader, you might say, well, this is how I feel. So how are you going to persuade somebody else to feel that way? Well, let's say beyond a reasonable doubt. That's what you need to prove. So if you can prove up to 76%, that this is the way it should be, that's usually what kind of an A paper starts looking like. If you're just proving 51%, that leaves problems. If you're not even hitting the 50% mark, that's even more problems. So you sort of see how inductive reasoning works then. Later in the course, papers 2, 3, and 4 are going to be on the same topic. So you're going to pick an argumentative topic. You're going to exhaust all the research. You're going to go through sort of a process of thinking that leads you to a conclusion. So if you think about it, something like the scientific method is a type of inductive reasoning. So the way the course is modeled, it kind of looks like the scientific method. So let's say I'm probably skipping a step here and there, but usually with the scientific method, you observe the world. That's usually the first step. You notice patterns happening. You form a hypothesis. So you notice all these patterns. You're saying, well, this is my guess as far as how these patterns emerge. Oops. So then you test the hypothesis. So this is where science falls apart. So you keep testing your hypothesis over and over and over, until beyond a reasonable doubt, nothing's going to change. So like whenever you do an experiment in like chemistry class, like maybe you test acids and bases, for instance, that's been proven 100 million times. That's true. But sometimes, like when scientists are trying to discover new things, in the testing stage, it falls apart. And then step 5, testing the hypothesis, you publish your results. So if everything checks out the first time, after many tests, you would publish your results, in maybe like a scientific journal, and then other scientists would do the exact same thing. They would test your experiment. So lots of times an experiment kind of falls apart, even in that stage. After it's been published, other scientists say, well, here's a problem in the reasoning somewhere. This has no sort of good grounding. And just to give you kind of a weird story, about a case like this, so the turn of the century, there was, you guys can Google this and read up on it, but there was a physician named Duncan Macdougall. And Duncan Macdougall, came up with the hypothesis, that there must be a soul in the body. So how did he prove that hypothesis? Well, he said, at the moment of death, I'm going to observe somebody dying and leaving the earth. So I'm going to weigh them right before they're dead. And then, like 2 or 3 minutes after death, he would weigh the corpse. And he would say, so his reasoning, he noticed over several instances, you guys can even read this, his writing on this, so if you Google it. But he said, well, pretty much every instance, the body lost, I think it was like half a gram or something like that. So he said, well, that means the soul is leaving the body. He also tested dogs, and dogs did not lose the half a gram. So he said, well, dogs don't have souls. So it sounds kind of crazy, which it is. But he went through he didn't test the hypothesis too many times. He went through like 10 tests. He got several different results a couple of times. I think maybe 6 of the 10 instances, the body lost half a gram. He also accounted for things like, well, when the body urinates or defecates, at death. He also accounted for that loss, of body matter. So question is, well, why isn't that, universal truth of science now? Why isn't that a scientific law? Well, mostly because no scientist worth their salt would test this again, right? It's kind of creepy, right? I mean, you have this guy, Imagine being on your deathbed and like this little Igor looking man just comes and weighs you, right? That's probably pretty annoying, somebody getting ready to die, right? It's also pretty creepy, so no scientist would dare test this again, without fear of losing their credibility. So I will leave that up to you. Maybe that is a true statement. Science just won't touch it. Maybe, right? Tune in next time to another episode of The Twilight Zone. So inductive reasoning. Maybe Macdougall had a point. Who will never know unless you do some very unethical experimentation yourself. So looking at this list then, we have all this. So one last thing I sort of want to leave you with today for tomorrow's class, you're going to be reading 2 articles. One of them is called Real Men Don't, Anti-Male Bias in English. The other one's called There Are No Unmarked Women. So, we're going to sort of dive into the realm of gender studies for tomorrow. But you're going to read 2 different arguments. So as you read, ask yourself, well, do I see a point one of these people were making? Did I think one argument's stronger than the next? Sort of prepare yourself to begin that paper by just asking, well, how much did August's article prove beyond a reasonable doubt? How much did Tannen's article convince me? If you can sort of like put a number on it, that's kind of valuable as far as breaking down their arguments. But I'm going to ask you tomorrow to summarize one of their arguments. So as far as summarizing an argument goes, like we just talked about with the syllogism above, you have statement 1 and statement 2 are premises, and statement 3 is the conclusion. So I will type that word out. Premises and conclusion. So a good way to do this is just ask yourself, well, what's the main idea, of the reading? What's the person trying to convince me of? That is the conclusion. So as you see, the title sometimes gives away the conclusion, right? Because you want to sort of grab the reader's attention for what they're getting ready to read. So as you'll see for tomorrow, August says, August's argument, real men don't, anti-male bias in English. Well, he's trying to prove the point that the English language has it out for men. So as you're reading it, ask yourself, well, what are the premises to the argument? What reasoning does August use, to try to prove that point? It's got several, 5, 6, 7 different reasons in the argument. So as you read, maybe try to list them. So you can even kind of do it like it's a mathematical proof. So reason 1, reason 2. I'm telling you this because if you're reading an argument, you're having trouble making sense of it. If you map it out in this way, it'll usually help you wrap your mind around whatever it is you're reading. This especially helps if you're reading something really theoretical and complicated. I have to do this sometimes when I'm reading something like literary theory. But tomorrow, before you summarize, try to list these out, in as much detail as you can. And then sort of after you have them all listed, you can easily write a summary of the reading because you have it diagrammed. August says there's an anti-male bias in English. His first reason is this. His second reason is this. So as you see, if you map it out this way, that'll help you write a summary. So try to do that for August and Tannen. That's going to be the discussion board post for tomorrow. But like I said, as you're reading it, ask yourself, well, how much do you agree with one or the other? Can you put a number, on how much you agree with one or the other? Answer that in the discussion board post too. Give me a number. How well were you convinced by each of the articles? So the first paper is actually going to be an evaluation of one of these articles. So if you can read it, sort of wrap your mind around it, summarize it for tomorrow, even put a number on how much you agree or disagree, that will help you sort of get in the right mindset for the first paper, which I'm going to put a lecture up on the paper itself without all this other stuff. It's the third video. So as always, I hope this was interesting material. I'm trying to give you a way to pretty much the main point of this whole lecture, the conclusion of the lecture, so to speak. Is writing is like the scientific method. If you go through a project, if you're trying to prove something one way or the other, you kind of have to go through this method. As you see, as you'll see through the whole semester, we're going to do different steps to this. The different steps will be the different papers. So you'll form a hypothesis early. I say you test the hypothesis, but you'll also gather data. You'll test the data. So gathering the data will be a paper. Testing the data will be a paper. The conclusion, the final argument, that'll be a paper. So the whole course is sort of geared around writing, reasoning. It's like science. The more a high number percentage you can persuade somebody, the more foolproof you're going to be. So with that said, as always, if you have any questions for me, tweet me, email me, put them on the discussion posts. That way everybody else can see them too. So with that said, signing off until the next video.